All right, hello and welcome to the second video in I think what I'm going to call the SQL for SQL Queries for Managers series. In the first video of this series, we looked at how to read a data model to kind of see what data you have available, how it's organized, how it's connected. That connection kind of gives us insight into how we can link tables together. All right. So now what we're going to do is we're going to look at the basic process of writing queries to actually use that data to answer managerial type questions. And what we're going to do is we're going to really look at sort of two versions of the query. One is the physical minimum. What do you have to absolutely use in order to actually get output? So anything less than that physical minimum results in an error. And then we're going to take a brief look at what would be the minimum useful query for a manager. And this is basically where we're asking some sort of question. All right. Now, in an earlier video, we're going to be part of this series, I looked at the syntax of the SQL select statement, its various clauses, a very detailed view, really a kind of a long video. So what I'm going to do is I'm going to put the link to that down in the description below. All right, so let's see if we can go ahead and get started. All right. So what we have here is an example of the minimum physical query that you can have. Anything less than this, these two clauses, and the query won't run. You just get an error statement. And really, it sort of makes sense if you think about it. Our first line, which is the select clause, which defines what we're going to see as part of our output, basically what are the columns that are going to be included in the output. This is, what do you want to display, or what do you want to output? There's very few things that you do on a computer where you're not going to get any kind of output, and so this is how we define the output for our queries. Then the next part is the place where we're going to get all that data from. See what I did there? Yeah, I'm not that clever. Okay, so we have to specify the sources of data, and again, the sources of data can be raw tables, like in this example, or they can be snapshots, which are time-based pictures of the state of data, or they can be views of the data. And we talked about what a view was in the last video. All right. So let's take a look at a straightforward example of how to write a real simple query that hits this physical minimum. And that might actually be practical in the office for you. Okay, so we have our business problem here. Provide a phone list of all of our employees. All right, so we want phone list, so that's usually that's kind of like an area code and a phone number sort of thing. We should probably also put the employee's name in there. Okay, so what do we want to see? Well, we want to see the employee's first name. We want to see their last name. Some places you have to have the area code as part of the phone number. So we'll go ahead and throw the area code in there, and we'll throw the phone number. So we can consult our data model, and we get customers, orders, employees. Okay, so employee first name, okay, we want that. The last name, we want that. Area code, that's the other thing we want, and then the phone number. Okay. So it looks like we can get everything that we want from the employees table. Now, we weren't asked to do any sort of filtering on employees. We want all of the employees. We're looking at the raw data, so we're not going to do any aggregation or grouping. And since we're not doing aggregation and grouping, we don't do any filtering on those aggregations. And there was no real order specified, although we could put that in easily enough, and probably before we finish up with this particular example, that's what we'll do. Okay, so let's go on over to Oracle. There we go. Okay, so I'm already logged in. Your login credentials, if you're part of the class or not part of the class may be different, but I have this data set up for my students. So we're going to, let's use the describe command, DESC. Okay. All right. So describe, DESC, sales order. Now this particular example is set up using an application schema. So we have a sales order application. It has a schema where it keeps all of its data. And then all of the user accounts have just been given access to do select statements on those tables within that schema. So you have to have the schema dot, which separates it as a separate component, and then the particular table within that schema. So go ahead and run that. You can use the little run button or just hit Control Enter and it thinks about it for a bit. And then down here at the bottom we have a list of all of the columns that are in that particular table. So first name, last name, area code, and phone number. Okay, great. Okay, so now we have a list of all of our columns. They're right here where we can see it. So let's go ahead and write our query using our plan. So we always start a query off with the select keyword. Sales order dot ease dot. We can go ahead and, if we want, we can pick it off the list here. And I'll kind of do that to save time. Comma. Ease dot imp last name, comma, dot area code. It's kind of reading my mind here. Now this is kind of getting long, so let's go ahead and move to the next line. Now, if you're going to move down to a line, never break. We always want to do any breaking right after after one of these comma, because the comma essentially marks off a column. Okay, so sales order dot employees dot phone number. All right. Okay. Sales order dot employees. Okay. And if we go back to our plan right quick, okay, we've got a list of all those columns. From that table, we don't have any entries for these other things, and nothing was really specified in terms of what order we wanted in. So that looks like we're done. Okay, well, let's see how that goes. And voila, we have our output. So we have first name, last name, area code, and phone number. All right, and you know that's actually kind of more complex than you see in a lot of examples, because we're going off to an application schema in an Oracle database to actually get our data. Okie doke. So that's it. Now that's the minimum physical query. Anything less than that is going to return an error. All right. We've listed out columns. We could use a star. That would just give us all columns. We'd get all columns and all records. So basically that would be a table dump. So we've taken our first step. Now, separate area codes and separate phone number and name in 2 columns. That's kind of weird. It's not really how you see telephone directories, really. Now, we can manipulate some of these things with some additional things that we can do in terms of providing aliases and also in terms of doing concatenation. Now, aliases are helpful in that they help simplify that whole sales order dot employee dot then the column name. That gets really tedious to write. We have the little pick screen come up, but that can get pretty tedious to write. So one of the things that we can do is we can give our tables aliases. So I could have done the whole sales order employees and then given it an alias, and then I could use that alias throughout the rest of my query. Also, in concatenation allows us to append values to each other. So I could put the standard US parentheses around the area code and then put the phone number in back, and that would all kind of look as one thing. I could take the name and have it last name, comma, space, first name, kind of like it looks in a phone book. All right. And finally, when we start doing these expressions that have all these components to it, the name of the column is that entirety of that expression unless you give it another name. And so one of the ways that we can simplify what our output looks like is to give our columns aliases. All right, so let's go back to our basic query that we just wrote, and let's clean that up a little bit. Okay? So let's see how much easier that is to write, and we'll put in our basic concatenation. So let's just start all over again. I can hit the erase button and just close that off. Okay. So all select statements start off with the select keyword. We're going to give the sales employees is going to be our alias for that table. And we'll call it imp name dot imp last name. And then let's do some concatenation here. So whenever we're doing a literal, which means we literally type the value in, we use a single quote. So single quote, open parenthesis. Then the symbol that we use for concatenation in Oracle is 2 pipe characters. Then we type in se dot imp area code pipe. Concatenate something else. We close that parenthesis and concatenate the next thing, which will be our phone number. All right, that looks pretty good. And see, that line is a whole lot smaller now that we're not having to retype sales order dot employee and then the name of the column. Okay, so that looks good. Let me see. We've got the column, okay, open paren. Then we got a concatenation, then a column, then a concatenation, then the close paren, then concatenation, and then the final column. All right. From sales order dot employees SE. All right, we got the semicolon there. That's our statement terminator. These can go on quite a while, so we put the statement terminator there. Okay, so let's see how that works. Oh. Well, not too good. Okay, so we can come down here. We can see our error. Okay, se dot phone number invalid identifier. All right, let's go over here to our list. EMPP. Okay, see, it always helps if you spell the name of the columns right. Now let's see how this bad boy works. Ah. All right, so we've got our name, just like we asked for, our last name, just like we asked for. And then we have that nice, if you're in the U.S., this is how our phone numbers look. Okay, so we've got the area code in the parentheses, then we've got the phone number. Now here's an example that I mentioned before, where the name of the column, it basically becomes that entire expression. Okay, that's kind of weird, difficult, not very meaningful if you handed this off to somebody. So let's use a column alias. It's kind of like our table alias, except it works on a specific column. So everything between the commas is the column's definition. So we just give it a space. I'm going to go ahead and use the as keyword. This is good when you first start out. You can leave it off, but I usually like to have my students put that in as they're starting off. And we'll call that ImpPhone. That's a cool sort of descriptive short name. And let's run it again. All right, see, a much more descriptive name for that column now. Okay, so what we've done here is we've written out a query that uses concatenation. We've simplified the listing of all of our columns, listing out those schemas with table abbreviations, or table aliases, I should say. And then we've seen how to use concatenation, and then now we've also seen how to use column aliases to give meaningful names to our columns. This is particularly useful when our columns are essentially expressions or the results of functions and that sort of thing. Alrighty? So let's pump this up maybe a little more useful type management query. We want to provide a list of employees, their 6-month review date, and a phone number where we can get a hold of them, and then we want to list this in alphabetical order. All right, so that sounds like something that we might find handy if we had to do some reviews. So what do we want to see? We want to see their first name, last name, area code, phone number, and their 6-month review date. Again, we go back to the data model. We have hired date here, so 6-month review date is 6 months after they were hired, at least in this particular example. So let's use that to base our math off of. We can get all of that from employees. We don't have any filtering, so we want to see it for everybody. That may not be very practical, but for this example, it'll work. We don't want any aggregation, and since we're not aggregating, we're no filtering on the aggregations. And then we want employee last name and first name as a sorting hierarchy. So let's go back over here to Oracle. And we sort of already have a lot of this all set up. So we've got their phone. So we can use the... Let me go ahead and break this line here. We want to keep every clause together and on a separate line. And if we have to have multiple lines, we want to keep them together with some indenting. It makes debugging these a whole lot easier. All right, so we're going to use a function in Oracle called add. I think it's called add months. It may be add month, which uses, we're going to use the hired date, comma 6. And then we're going to give this also an alias because that would just look weird. We'll call it initial review. So it's 6 months after you're hired, you get a review. And again, we're getting this from employees. And we've also asked for some sorting. So for sorting, we use order by. Now, this is not necessarily required, but this is always a good time to kind of throw this in. And so we want it by last name, comma, first name. Now, and you can just type those in if you want. All right, so last name. I could have also put 2, 1 because you can put the placement here in the select clause. That's another way to do this. But personally, I just like to list out the actual values. Makes it a little more stable in case I forget to rework my order by if I change the order of my columns in the select clause. Little helpful tip there. All right, so that, if I've got the name of the function right, that looks pretty good. Okay. Well, I did get the name of the function right. It's a little hard to tell though, so here's another little tip is if you have the room, it's always good to put in the thing that you're doing the math with. So SE dot and I spelled that right. Yep, that's good. Okay. Now let's run this again. All right, and that's a little easier to see that you're actually doing the math correctly. I call it managing the warm fuzzy feeling. Okay. And that looks good. All right. So moving along, now we have this concept of the minimal useful query for a manager. Now, what we've been doing so far is we've basically been just dropping the entirety of the table, everything. Okay, that for little tiny tables, for an example like this, that's okay. Probably would not recommend dumping the entirety of something like the American Express daily transaction log to your machine. You might get a visit from somebody. Okay, so we want to make this really useful for managers. We really need to set up criteria. Now we're not going to get too crazy with this. We're just going to look at where does the where clause fit in there, and look at a little bit of example of how we can set up a description of what we want to look at so that we can just get the useful information that we need. So our minimum required query, we have to have this to keep the thing from erroring out. And then really to keep from getting all of the records in the data sources that we specify, we have to put in some sort of filter. Either that or we have to aggregate the records. That would be another example, but that's for a later video. All right, so without any kind of filter, you get all the records. So we're going to look at how to put a filter on. So a simple decision-making example. So we want to provide a list of orders that do not meet our service target of shipping within 3 days or less. So we're looking at orders where the ship date is more than 3 days out from the order date. So we want to see the order ID, so we know what order it is. We want our basic items that we're using in our math here, so we can kind of check that out. So we get order date and ship date. And then we want that elapsed time to see how much it was out. If we go to our data model, okay, we can get order number, order and ship date. We don't have a difference between the two, but that's okay because we're going to do some date mathematics. That's an interesting thing that we can do in database platforms. Why? Because database platforms support business and businesses do date mathematics. All right, so that seems to be all the data that we need is that number and that, and then we can create a third piece of data called this elapsed time by basically subtracting our order date from our ship date. All that comes from orders. Now we only want it where that elapsed time is greater than 3 because those are the orders that don't meet our service agreement. Those are the ones we need to focus our attention on. We don't need to be thumbing through a list of everything. All right. We don't want aggregations. We want actual records. Since we have no aggregations, we don't have any filtering on aggregations. And we want it sorted by elapsed time. That way we can see the worst offenders first. Or at least we can put them in order. Okay? So let's get to it. Back to Oracle. Okie dokie. So what I can do is give myself a new little object. Okay, I'm just going to get a little SQL file. I'm going to call it bad shipping. I think I want to put it in a better place than that. I'll just stick it on the desktop for now. So, again, if we're confused, we can go see. Tell it what connection here, because this is a new file. All right, and then we just have a list right down there. As we saw with my spelling problems last time, that's probably not a bad idea to have that. Okay, so again, we start off all queries with the select clause, and we want, we'll just call it O for order. Dot from sales order dot orders O. Okay, that makes my alias work now. And we're going to have to put in the where clause. So we want dot minus date minus O dot date greater than 3. And okay. So you're going to say, well, how come we didn't just put elapsed time right here in the where clause? Well, discussed in an earlier video, the where clause gets executed a lot earlier in the process on the database management system. So pretty much the only clause that we can use these column aliases in is the order by clause. And it's probably a good idea if I put some math in there. That would be good. In fact, let me put that in some parentheses so we know that it's all one piece there. Okay. So that's one statement. We even have the get big or get little symbol there. So let's see how that works. Ah, nice. Okay. It looks like pretty much if we miss that 3-day, we're only missing it by 1 day. Okay, so we could make some management decisions. Maybe we want to make our shipment time larger because we seem to be doing pretty good, or maybe we can find out something about those orders that's taking that extra day. Maybe there's something special about those orders that makes us take one more day. So. If we're offering some sort of reward to customers if it takes too long, then we need to look into that. So that's a basic manager example. We can go and look at how our process is working. Not a completely unreasonable or uncommon example of something that you might have to do in the workplace. If you're a manager, trying to keep control of your processes. that's pretty much it for this video. It kind of got a little long, but I think we hit on some good pieces. If you have any questions or comments, if you're a student in my class, you can use the classroom discussion forums, whether you're a student or not. But you can also hit me up on Twitter at the Dr. Barnett. Remember to thumbs up, heart, or whatever it is that you do on this particular site if you want to. If you don't, no big deal. And also feel free to use the comment section below if you have some suggestions or want some refinement. That's it for now. Go out and do something with that data.